just wanted to give a quick look at the standards for statistics and probability numbers 1 and 2. A lot of these are a lot of reading. A lot of these problems have a lot of words in them. So here's a question that asks a random selection of 84 students. So that's the total number of students he asked to name their favorite fruit. It tells me 16 chose strawberries, 26 chose oranges, 24 chose watermelons, and 18 chose apples. I'm going to put those numbers next to these fruits just so I can keep track of them. 16 chose strawberries, 26 oranges, 24 watermelons, and 18 apples. If there were 420 total students, how many students would choose each of these fruits based on the survey results? So the math is fairly simple. You've got to figure out 84 times something is 420. And whatever that scale factor is, I'm going to take the 16 times that number. I'm going to do the 26 times that number, the 24 times that number, and the 18 times that number. And that'll tell me the values. But this problem is one of those unique problems that gives you all the answers, and you have to match one with another. So if you look, if you're smart, you can say, well, the fewest is strawberries, the next fewest is apples, the next fewest is watermelon, the next fewest is oranges, and most is oranges. I've got 4 different numbers here. The smallest number is 80. I bet strawberries goes there. That makes sense. The next smallest number would be for apples. Oranges is the most, and watermelon is next to most. Let's see, 84 times 5, I think. You do 420 divided by 84, you get 5. 16 times 5 does happen to be 80. 18 times 5 does happen to be 90. And so on and so forth. Okay? So this one's one that I could just logic my way through without doing any math and just look at the numbers. Smallest goes with smallest, largest goes with largest, etc. Company making cell phones, they took a sample of 200. They manufactured 14,600. So 200 times what is 14,600? Okay, that's 2. Let's divide 146 by 2. That's 73, and I'll put my 2 zeros back on. Well, actually, I don't have to because those are 2 zeros there. 73. So, if 3 were defective, 3 times 73 is 9, 219. Number C, letter C. Same deal. My sample's 50. I'm going up to 3,200. 50 times, 64, I think, is 3,200. So that's how we're scaling it up. And the reason I think about that is I think every one of these hundreds has 2 of these. So if I have 32 hundreds, 32 times 2 is 64. So based on the results, about how many are expected to be defective? So 4 were defective. 4 times 64. 4 times 4 is 16. 4 times 6 is 24. 256. All right. Football game. 40 fans were surveyed. That's the sample. There are 12,000 fans. So, 40 times what is 12,000? So you take a 0 off. 4 goes into 1,200 300 times. Of the sampled fans, 6 say Darren's the best player. So 6 times 300 is 1,800. That's B. Based on her data, what's a good prediction for the number of lemonades she's going to sell on Sunday? So this is the data she took leading up to Sunday. We're looking at lemonades, so that'd be this column here. She sold 33, 40, 35. So somewhere in the neighborhood of 33 to 40. The closest one to these numbers here is a 38. That's what I would predict. That's a reasonable guess. Robert is surveying 10 ninth grade students to determine their favorite color. Of the 10 he surveyed, 5 chose yellow. So Robert's claim is that half of the people at Lincoln High School will choose yellow as their favorite color. So he chose 10 people, and 5, that's half of them, chose yellow. Which is the best explanation as to why his claim is not accurate? So his claim is that half of all the students will choose yellow. He only surveyed ninth grade students, so that is a problem. Students from one school, well, that's the school he's looking at, so that's not a problem at all. He's only looking at school students at Lincoln High, and that's the only claim he's making is about Lincoln High. Only 10 students were surveyed about their favorite color. That's a problem too. And it says only 50% of them chose yellow as their favorite color. That's not a problem. The problem is in the method, not in what the results said. The method makes his claim less likely to be accurate. He only surveyed ninth grade students, but the biggest problem is he only picked 10 students. Presumably there's hundreds of students at the school. 10 is a very small sample, so I would go with this guy. Let's see, she wants to know about the tardy policy. Who should she ask to get the most accurate results? So if you think about people who are often tardy, they might not like the tardy policy. People who are never tardy, they might not care at all. So those guys are going to give her biased results. 30 of her friends. Well, depending on who her friends are, she's going to have pretty biased results. That you got to pick randomly selected students from the entire school. That's the only way it's going to be a fair representative survey. Ms. Johnson is a principal at a middle school. She's taken a survey to see about interest in a 7th grade chess club. So is she going to survey a football team? That's excluding a whole bunch of 7th graders. Is she going to survey the parents of 7th graders? Those aren't even the people who care about having a chess club. Every third who walks into the office. Why are people in the office? Not everyone goes to the office. But if you pick every 5 students who comes in through the building, that's going to get just about everybody a chance to be picked. Henry's doing a survey to determine students' favorite after-school activity. So you pick chess club, you're going to get kids who like chess already. Some 7th graders, the tennis team definitely not. He's doing it for all the students. So the 7th graders, that's a little problematic. But if we pick every 5th student entering the school, that'll do it. Problems like this are confusing sometimes because they'll say every 4th person coming off a bus. Or something like that. The every 4th person coming into school, I mean, that's be fine. If it was coming into the school, that's fine. But people coming off a bus are just bus riders. You're never going to get people who walk. You're never going to get people who carpool. So that is that.